Okay, let's continue. So now we have a proposed model here. Now I want to solve the model. Okay, I want to solve the model. And solving a model means try to find some values of my decision variables so that the values do not violate any constraint and the objective function is maximized. Okay, so for example, I can choose to carry no book, then it's 0, 0, 0. That's okay, but it's not a good idea. I probably want to set, for example, x1 to be 1. If x1 is 1, then I'm okay to do that and I can earn $500. That's better than earning no money. Okay, so that's fine. That's fine. And starting from next week, we will try to tell you how to systematically solve any model. But here, I just want to point out that if we look at this definition, this model carefully, we will see the following thing. We will see that this problem is actually unbounded. Unbounded, what does that mean? Unbounded means this problem has no best decision because given any decision, you can find a better one. Okay? Or say it in a mathematical term. Given a problem here, any solution has a better solution. What does that mean? For example, if I choose 0, 0, 0 as my solution, then it's feasible, which means it's fine. And the result is not good. I can then say, okay, how about this? I'm going to deduct x1 by 1 and increase x2 by 2. I can do that because I know the sum of the three numbers here would still be 0, right? And I can earn $300 because 400 times 2 minus 500 is 300. Okay, that would be a better solution. And if I can do that once, I can do that twice and earn more and so on and so on and so on. So if I really put this model into a solver or handing to someone that can solve the problem, there would be no optimal solution. And of course, we know that means the model is wrong. Okay, that means the model is wrong. So why is that? We know that we actually cannot carry negative amount of books, right? So probably we missed one constraint. We probably should have another set of constraints saying that xi cannot be negative. Okay? That's reasonable. That's reasonable. And according to our previous experience, it seems that we really need that. Okay, so we refined our model. Okay, please remember, when you have a problem, you try to formulate a model and then try to solve it. And then you need to verify your solution to see whether your model is good enough or whether it is appropriate, whether it is correct. In this example, in the previous slide, we showed you that, okay, according to the analysis of our problem, we know that our model is wrong. So that's why we refine our model by adding this constraint. Unfortunately, it's still not right. Even if we set all these variables to be non-negative, the best answer here would be to set x2 to be 2.5. Okay, if you look at these parameters carefully, you will see that if I have really a lot of book 2, then this is the most economic choice because the price over weight, the ratio is the largest. And then I would try to put them as much as possible until the backpack is full. That means 2.5. And again, that's impossible. That's violating the physical restriction. So how about this? I'm going to say that, oh, okay, for each book, I have at most one book. I cannot carry 2.5. So this is another refinement. Unfortunately, it's still not enough because if we hand in this model to a solver, the best solution would be here. I'm going to carry one book 2 and the 3/4 book 1. So I'm going to split my calculus textbook and sell only the first 3/4 to some student who want it, and get some amount, not 500, but the proportional amount. So that's again not possible in this question. So that means our model is still not good enough. The constraint that we really need is that we cannot split a book. So our xi can either be 0 or 1, but nothing else. So this is a set. When you put numbers into a pair of curly brackets, that means that's a set of 0, 1 in this example. And this means xi can only be one of these numbers, either 0 or 1. So this is our final formulation, which is finally right. If we put this as our model and put that into a solver, the best solution that the solver will give to us is 0, 1, 1, 0, 1, 1. That means I'm going to carry book 2 and book 3 and not violating my physical restrictions. If you have some experience in algorithms or computer programming or something like that, you probably know that this problem is called a knapsack problem in computer science, okay? And this is a very fundamental problem that is applied at many different places. That's why we say a model is useful, because today we are talking about books and backpack. Maybe tomorrow you will deal with another problem, is that you have a limited amount of time and you have several projects to work on. Then you need to decide how to split your limited amount of time to various projects to maximize your return. Okay, or you have some money you want to invest in a few stocks. Then you decide how to, for example, maximize your return or minimize the risk, subject to your return must be at least a certain amount, something like that. So as long as you can model a problem, then you can model a lot of different problems. And then you don't need to design methods to solve each different problems. You only need to design methods to solve models. Okay? That's easier and more powerful. Okay, so don't forget that before you finish your the whole OR study, don't forget that we do OR study not just because we like mathematics, or we know we do like mathematics, but what we really want is to solve problems, to find suggestions. So the last step is always to make managerial suggestions if you are solving business decision-making problems. So if you are writing a report to your boss don't want to see 0, 1, 1. That means nothing. The boss wants to see suggestions. That means you need to interpret your solution. In this example, it's simple. The conclusion would be the following. Given our model and the solution we obtained, we suggest you to sell the textbooks of computer programming and OR. This is the exact action plan, exact suggestion to the decision maker about you should do this and do that. Okay, that's the interpretation part. In practice, a model is always some kind of simplification from the reality. Okay, so that means our optimal solution from our model may need some adjustments to be applied to the practice. That's possible. Okay, but of course, that depends on experience, depends on intuition, because depends on those constraints that cannot be quantified, and that's the decision makers, the job of the decision makers. As OR researchers or OR study planners, we suggest solutions, suggest plans to the decision maker, and then the decision maker may need to do some manual adjustments. That's still possible. Okay, so as a summary, an OR study is conducted in the 5 steps. First, we define the problem, and then we formulate a model, try to solve the model, check whether the model is good enough, and as we are satisfied, we make suggestions. In this course, we focus on formulating a model and solving a model. What does that mean? We will give you a lot of training about given a realistic problem, how may we formulate a model that can represent the problem while solvable. Okay, that's very important. Gradually you will see we can always construct very complicated mathematical models to express the real world. But a too complicated model is useless because we must be able to solve the model so that we can make suggestions. Okay, so we will go from here and here back and forth. We teach you there is some ways to solve, to formulate problems. And then we tell you there are some methods that we have to solve models. Then you will be able to decide, oh, okay, I have a problem, and if I formulate it in this way, it is solvable. If I formulate in that way, it's not solvable, something like that. Then it's important for you to do that because then you can decide whether you are satisfied with the current model or not. Okay, you will see the details. So the reason that we want to focus on these two parts is the following. These are technical parts. Okay, technical parts are not so interesting, but the thing is that they need practice instead of experience. As first year, second year, or as young students who do not really have work experience, this may be the best thing to study when you are still at school. If you want to learn something that may be helpful for you to solve business decision-making problems, in my opinion, it should be techniques instead of those things that really requires experiences. Okay? Given that most of you do not have real work experience, this course should focus on techniques. And in the future, when you get experiences, you apply the techniques in a way that you like it in your particular domain. You will do step 4 by yourself from time to time, and we will still give you some taste about problem definition, data collection, and solution interpretation when you do your case study and the final projects. Okay, so that's the basic planning of this course. Okay, the last thing I want to use just 1 minute to tell you is something called a DFSI principle. So that means in this course in particular, when you are asked to solve a decision problem, then you must do the following 4 things. First, you need to formulate the model, and formulating the model always starts from defining your decision variables and all the notations you use for your parameters. You need to do this at the very beginning because different people can have different ways to define their decision variables. So you need to clearly, precisely tell us what are your decision variables and what do they mean. Only after that you may formulate your model and tell us, given your definitions of decision variables, how would you express your objective function and how would you express your constraints? Okay, this too gives you the precise description of your model. And then you need to solve the model, either by finding the value of all the decision variables in an optimal solution, or tell us the model is infeasible or the model is unbounded or something like that. You need to analyze the problem, the model, and then give us a conclusion. And that part is still mathematical, but finally you need to convert those numbers back into what to do, back into an action plan. So you need to interpret your numbers. Okay, so we call it a DFSI principle, the 4 steps to go through when you answer one question or when you do a study in this course in the field of operations research. Okay, that's the end of our introduction to modeling, mathematical modeling in operations research. Thank you.